Hi, this is Miss Pellegrin, and today we're looking at Module 4, Lesson 7, Markup and Markdown Problems. So when we're talking about a markup, hence the word up, we're talking about a price that the original price is going up. So we have also our markdown, so the price of the original is going to be going down. So we have our percent. And remember, this is just one way to do it, but it's the way we are going to concentrate on doing it. And so we take our original, we add it to the markup. We take the original and we add the markup, and that is going to give us our sale price. And then remember, this is a percent. So, sale price. Okay. And then we're going to take our original amount, and we're going to take off any discounts or markdowns. In order to get the sale price. So in this, we're going to be looking at more of the percents. Students understand the terms original price. So the original price is what you're starting with. Selling price is how much they're actually going to sell it to you for, whether it's marked up or marked down. So if they're marked up, then they're going to be making a profit from the original price that it was. If it's marked down, they're going to be probably losing some money. Markup rate, so how much is it being marked up, the actual amount, and then markdown rate, and so that's again the actual amount. So these are more of our markups, and markdowns are our percents. Students identify the original price as the whole. So the original price, so when we say original here, that's the whole, so that's going to be your 100%. So your original is your 100%. And use their knowledge of percent and proportional relationships to solve multi-step markup and markdown problems. Students understand equations for markup and markdown problems and use them to solve for their unknown quantities in such scenarios. So let's look at example number 1. A video game markup. Games Galore Superstore buys the latest video game at a wholesale price of $30. So wholesale means you're buying it kind of in bulk, like if you were to go to Sam's. $30. The markup rate at Games Galore is 40%. So we said markup rate is a percentage. You use your allowance to purchase the game at the store. How much will you pay, not including tax? So first it wants us to write an equation to find the price, and then explain your equation. So part percent whole. Okay. So we have that 40% that we could use, but we're not going to be working with that 40%. And that's not the way we're going to be looking at it. It is a possibility. It's a way we can do it, but we're not going to be looking at it that way. Okay. So at the top we wrote here, we said original plus the markup, and this was a markup. So the original was 100%. Plus, so they're taking 100%, which was the original, plus another 40% that they're adding on. So that gives me a total of 140%. So move that decimal 2 places to the left. So our percent that we're going to use is actually going to be 1.4. Remember, our whole is going to be our original, so 30. and we're looking for the part. So we're actually looking for how much are we going to be paying. So our equation is going to be part is equal to percent times the whole. So our equation is x is equal to 1.4 times 30. So this is our equation, and then the way we got it, because it said to explain, is we took the original percent, which was 100, plus the markup rate, which was 40, which gave us the sale price. Which is going to be 1.4. And sale price, not $1.40. That's what we're going to be multiplying the original by, the original price. Okay. Part B asked me to actually solve the equation. So x is equal to 1.4 times 30. That was my equation. So all I'm doing is multiplying. And I'm multiplying 1.4 times 30, which gives me 42. So x is equal to 42. So that is my sale price. So $42 is the sale price. That's how much I'm actually paying, and that makes sense. It's a markup, meaning it's going to be more than the original, which is 30%, or $30, and it's 40% more than that. So that does make sense. See, what was the total markup of the video game? So not the percent. How much money extra were we paying is what it's asking us. And so if it was $42 when we bought it and they paid $30 for it, we had a markup rate of $12. So that's our sale price. And we subtracted the original price, which is what gave us our markup. So in other words, how much money are they going to be making? So they bought the game for $30. If they sell it to you for $30, they're not going to be making any money. So they marked it up to $42. So that's how much you're paying before that tax. And so they're making $12 profit. You and your friend are discussing markup rate. He says that an easier way to find the total markup is by multiplying the wholesale price of $30 by 40%. Do you agree with him? Why or why not? Okay, so markup rate. And he says the easier way to find the markup, so the $12. And he said that the easier way to do that is to take $30, the 30, and multiply it by 40%. So that would be 0.40. And so when we do that, 30 times 0.40, we still get that $12. And so that gives us that markup rate. Okay. So why or why not? Yes, I'm going to agree with him because it still gives me the markup price. Let me erase this. Yes, because it's still 12. And so therefore the markup rate is 40% of, and that word of means to multiply, 40% of the original, which was $30. Let me say original. 40% of the original. And that means to multiply. But this only gives me the markup, not the total price. So in order to get the total price, you would have to take that 30 and then add the 12, and then that would give you your $42. Okay. Again, both ways are acceptable. Working on one way rather than the other is the way we're more practicing. Example number 2, a $300 mountain bike is discounted. Okay, discounted means it's going to be taken off by 30% and then discounted an additional 10% for shoppers who arrive before 5 a.m. Find the sales price of the bicycle. Okay. And I know what you're thinking. Okay, well, they're getting 30% and then 10% additional, so let's just add that together. But actually, you can't do that. It actually ends up being a different amount. So we actually have to do it one by one. Okay, we have to do the first discount and then the second discount. So, part, percent, and whole. So my part, actually let's start with the percent. So it's discounted by 100, so we said we're going to take our 100 that it originally is, we're going to subtract the discount percent, and so the total that I'm paying 70% of that bicycle. So that's what we're going to use as our percent is 0.70. And then our whole, or our original, was 300. So our part is what we're going to be looking for. So part is equal to percent times whole. X is equal to 0.70 times 300. X is equal to 0.7 times 300. Gives me 210. Okay, so if I don't get there before 5 a.m., I'm paying $210. However, if I do get there before 5 a.m., then from that $210, I get to take off another 10%, and that's why we can't put them together, because you're getting the discount, it's bringing it down to 210. So our whole isn't going to be 300 anymore, and so that's why we can't actually put them together and why we get different answers. So part, percent, and whole. We're having our original taken off 10%. So how much of it am I actually paying? So that's what we're using, is we're using how much are you actually paying for it. And so we're paying 90% of it, so 0.9. Our whole is 210 in this case, because we got that 210 from how much it was after the 30% discount. And part is our X. So part is equal to percent times the whole. The part is X, percent is 0.9, the whole is 210. X is equal to 0.9 times 210. 0.9 times 210 gives me 189. So if I get there before 5 a.m., now I'm only paying $189 for the bike. Okay, so 189 sale price before 5 a.m. and then 210 is just the sale price. In all, by how much has the bike been discounted? In dollars, explain, and you will find that in part 2 of this video.